I believe you had a great opportunity last night to look up at the sky. Everything that you see out there also emits radio waves. So that's the first thing. Everything that you see emits a radio wave as well. In fact, light is just a kind of radio wave, but in terms of what these dishes measure, all those things emit radio waves as well. That's the first thing. Some of the things you can't see out there also emit radio waves. So that's another reason why we want to have a radio telescope. So what we do is we design an electronic instrument that can capture the radio signals that emanate from space, and we can then detect, is that radio signal there or not? And that tells us something about the physics or the processes that create those radio signals. And different kinds of physical processes generate different kinds of radio signals. So let's take the simplest one for this example. Let's take neutral hydrogen. Hydrogen, the most basic element in the universe, very simple. Turns out it has a radio fingerprint. It emits a radio signal at about 1.4 gigahertz. You know what that is? Great. If you don't, just know that there is a radio fingerprint associated with neutral hydrogen. What does that mean? You can build a receiver, much like your receivers in your car when you want to tune to a radio station, and tune it to that frequency and see, is there any radio signal there or not? If there is radio signal, then what does it tell you? There's hydrogen there. If there's no radio signal, what does it tell you? There's no hydrogen there. The strength of the signal tells you how much hydrogen is there. So now sitting on the Earth, you can look out into the universe and you can probe the universe and find out where there is neutral hydrogen in the universe. So that's the very basic premise of radio astronomy, is you want to detect those radio signals. Now, of course, just knowing that there's hydrogen out there is a useful thing to know. But if you want to understand the universe a little bit better, you want to know where that radio signal is coming from. You want to know where in the universe is generating that radio signal. And so now what you start doing is you start building dishes. Because what a dish allows you to do is a dish allows you to focus just on a certain patch of sky and see, is there any radio signal coming from that patch of sky? Turns out, the bigger and bigger and bigger and bigger you make the dish, the smaller and smaller and smaller patch of sky that you can become sensitive to. So if you imagine, if you want to build a picture of the sky, you build a massively big dish so that it focuses just on a very small patch of the sky, and then you just scan over the sky over and over and over, very similar to the way old printers used to work and the way that some scanners work by scanning the sky over and over and over again. And that'll give you the very detail of where that radio signal is coming from. The problem is, it's very difficult to build big dishes. It's very expensive to maintain big dishes, and so there is a limit. And it turns out that we discovered that instead of building one big dish, we can build lots of little dishes and add them together as though they were one big dish. And that's what you're seeing here on the site. You're seeing lots and lots of dishes that in their own right are sensitive to the sky. Turns out how much of the sky? When you look at the moon and you see how big the moon is, that's roughly the size of the patch of sky that these dishes are sensitive to, as a good example.
Together or one?
No, one dish. One dish is sensitive to that patch of the sky. What we then do is we point all the dishes at exactly the same patch of sky. And then as the radio signal comes from that patch of sky and arrives at our array, you can imagine that if it's coming from directly above, it'll arrive at all the dishes at exactly the same time. If it's coming from slightly to the side of that patch of sky, it'll arrive at some dishes slightly before it arrives at the other dishes. And if you can measure that difference in arrival time, you can tell where in that patch of sky the radio signal is coming from. And so that allows us to now build a very detailed picture of what the radio emission looks like in that patch of sky. And so where's the limit then? There is no limit. The more and more and more dishes you add, the weaker and weaker signal you can see from that patch of sky. The further and further and further you move those dishes apart, as long as they can still all see that patch of sky, the finer and finer detail you can see of that patch of sky. And so now you have an interferometric radio array where it's now able to make images of the sky in that patch. And now you can point those dishes at different patches of sky, and so you can then build up images that you see in the science journals and stuck up on the wall and so on. So that's the basic interferometry, radio astronomy 101, why we build arrays, why they look like they do, why we move the dishes as far apart from each other, just to make as much detail as we can inside that patch of sky.